Hello everyone, welcome to our first physics online class. Let us start with the first chapter of class 11, that is physical world. This chapter mainly explains what is science, branches of science, what is physics, branches of physics, scope of physics, fundamental forces in nature and laws of conservation. Now let us move to the first concept. What is science? Science is a systematic understanding of natural phenomena in detail. The word science is derived from a Latin verb scientia, meaning to know. For example, science explains why the sky appears blue in color. This is because of the scattering of light rays across the atoms and molecules which are present in the atmosphere. Also, science gives an explanation why the plants are green in color. This is because of the presence of a pigment called as chlorophyll. These are some examples of science. Now, let us move to the branches of science. Science is a very vast subject. The branches of science are physics, chemistry and biology. Now, let us understand what is physics. Physics is the study of basic laws of nature and their manifestation. Physics is the study of physical world and matter. Word physics is derived from a Greek word physis, meaning nature. It implies that physics is the study of nature and their rules. Physics studies about the states of matter at the atomic level. For example, physics explains why an apple from the tree falls towards the surface. This is because of the presence of gravitational field of the earth. Now, let us understand the two basic quests in the physics. One is unification, second one is reduction. Let us learn them one by one. What is unification? This is an approach which considers all of the world's phenomena as the collection of universal laws in different domains and conditions. For example, laws of gravitation applies both to a falling apple from a tree as well as motion of planets around the sun. Second one is reduction. This is also an approach. This approach derives properties of complex system from the interaction of its constituent parts. For example, the temperature studies under thermodynamics is also related to the kinetic energy of molecules in a system. These are the two basic quests in physics. Now, let us know the branches of physics. Here I have considered 7 branches of physics. Let them know one by one. First one is thermodynamics. Thermodynamics is the study of heat and temperature, how the heat moves from one system to the another. Second one is optics. Optics is the main branch of physics which deals with the study of light and the phenomena which comes under the light, such as reflection and refraction. The third branch is electromagnetism. Electromagnetism deals with the study of electric fields and magnetic fields. Together, study of electric and magnetic field is known as electromagnetism. Next one is nuclear physics. Nuclear physics is the study of nucleus of an atom at its constituent level. For example, protons and neutrons are the parts of a nucleus. The study of its parts and the whole nuclear behavior is known as nuclear physics. Next branch of physics is astrophysics. This branch mainly deals with the study of astronomical objects such as planets and stars. The next branch of physics is classical mechanics. This branch of physics deals with the study of laws of motion at the macroscopic level. The last branch of physics is modern physics. Modern physics deals with the study of interaction of the matter at the atomic level. These are the few branches of physics. Now, let us move to the scope of physics. Scope of physics is the vast as it covers quantities with length, time as well as mass. Scope of physics tells us the range of length, time and mass. The range of length lies between 10 raised to 40 meter or more and as low as 10 raised to minus 14 meter or less than that. Similarly, the range of time scale goes from 10 raised to minus 22 second to the 10 raised to minus 18 second. And the range of mass goes from 10 raised to minus 30 kg, that is the mass of an electron, to the 10 raised to minus 55 kg, that is mass of the universe. The scope of physics explains the ranges of length, time and mass. Now, let us understand fundamental forces in nature. There are 4 fundamental forces in nature. These are the basic forces that exist in our nature. Let us know them one by one. First one is gravitational force. Gravitational force is the main fundamental force. This force with which earth pulls everything towards itself. It is the force of attraction between particles of matter. For example, a ball thrown upwards returns back to the earth due to the gravitational force. This force is of infinite range. This force exists between the planets as well as the atomic level constituents. Now let us understand what is electromagnetic force. Electromagnetic force is the one of the fundamental forces in nature. It is the force between charged particle. Charges can exist in two states, either positive or negative. There is a force of attraction between unlike charges, that is, there is a force of attraction between positive and negative charge, and there is a force of repulsion between like charges, that is, two positive charges repel from each other, also two negative charges repel from each other. Charges in motion produce magnetic force. The together study of electric forces and magnetic forces is called as electromagnetic force. Now, let us understand the strong nuclear force, which is the strongest forces in the fundamental forces in nature. Strong nuclear force is the one which holds the nucleus together. Because of the electric repulsion between the protons in the nucleus, one proton repels from the another proton within the nucleus, and hence the nucleus becomes unstable. This instability is balanced by the strong nuclear force. This nuclear force holds the nucleus and makes the nucleus stable. It is the strongest force in the nature. The range of this force is of 10 raised to minus 15 meter. Now let us understand the last force, that is weak nuclear force. Weak nuclear force is stronger than gravitational force but acts over a very short range distance. This force is responsible for beta decay, and this force also creates radioactivity. These are the four fundamental forces in nature. One is gravitational force of infinite range, and all the objects in the universe are operated by this force. Second one is weak nuclear force. This force is of very short range of 10 raised to minus 16 meter. This force operates between elementary particles and electron and neutrino. Third one is electromagnetic force. The range of this force is infinite, and this force operates among charged particles. And last one, strong nuclear force. This force is of short range force of 10 raised to minus 15 meter, and this force operates among nucleons and some heavier elementary particles. This is about the fundamental forces in nature. The strongest force among this is strong nuclear force, and the weakest force among the four is gravitational force. Now let us move to the conservation laws. Before learning the conservation laws, we must know what is a conserved quantity. A conserved quantity is one whose value remains constant during the process. For example, a ball is thrown upwards and hence it returns to the surface because of gravitational field. The mass of the ball remains constant throughout this process, and hence the mass of the object is called a conserved quantity. A conserved quantity is nothing but whose value remains constant throughout the process. Now let us learn the conservation laws. There are four conservation laws in physics. First one is conservation of energy, second one is conservation of mass, third one is conservation of linear momentum, and fourth one is conservation of angular momentum. Now let us study them one by one. First one is conservation of energy. This law states that energy neither be created nor be destroyed, but it is transferred from one place to the another place. This law states that energy is neither created nor be destroyed, but it is transferred from one form of energy to the another form. Let us consider few examples. An automobile engine changes chemical energy to mechanical and heat energy. Here chemical energy is nothing but fuel provided to the engine. Chemical energy is converted to mechanical energy, that is the fuel changes from chemical state to the mechanical state. Mechanical energy nothing but the car moves from one place to the another place. Another example is thermonuclear reaction. Here nuclear energy is changed to radiant and heat energy. Another example is a tree changes radiant energy to chemical energy through a process called as photosynthesis. These are the few examples of conservation energy. Now let us move to the law of conservation of mass. This law states that mass is neither created nor destroyed. It must start with the same amount and also end with the same amount. For example, we are going to burn a wooden of 30 kg with fire of 1 kg. This leads to the ashes and smoke of masses 28 kg and 3 kg respectively. Third law of conservation is law of conservation of linear momentum. There are two bodies of masses m1 and m2. Before collision, the velocity of mass m1 is u1, the velocity of mass m2 is u2. After collision, the velocity of both the masses changes. The velocity of mass m1 is v1 and the velocity of mass m2 is v2. This law can be expressed in the form of equation, that is m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. It implies that the product of mass and velocity remains constant throughout the process. This is the explanation of law of conservation of linear momentum. The last law is law of conservation of angular momentum. Let us consider a lady performing a dance. In her dance, she is rotating around herself. The extended arms of her means larger the radius and smaller the velocity of rotation. Bringing in her arms decreases the radius and increases the velocity of rotation. It implies that the radius of rotation and velocity of rotation are inversely proportional to each other and their product remains constant. This is the significance of law of conservation of linear momentum. In this chapter, we have studied what is science, branches of science, what is physics, branches of physics, scope of physics, quests in physics, fundamental forces in nature, conserved quantity and laws of conservation. Thank you everyone.